So we're looking at an expression for the potential energy when it comes to springs. So first thing is, let's look at the very obvious or very simple case. The work done by the spring force for a small displacement of dx. We have dws is equal to fs, force into displacement, right? We know that force is given by minus k x dx. This is from Hooke's law. Hooke's law. So this is a fundamental idea. This is for a small space. Now, what if we move it for a big space, from, say, the spring moved the object from xi to xf. So it moved it in this manner. If the block is moved from an initial position of xi to xf, then the total work done by the spring. How will we find it out? Yes, integration. So we need to integrate from all the parts from xi to xf, fs or minus kx dx. You guys agree? Then, so how do you integrate this? What do you get? Very simple, right? This is minus x, sorry. Let me change the color. Minus x, and this is x square by 2. We have xi to xf. Okay, and then we have the work done by the spring. Let me substitute subscript it. So xf square minus xi square. So this is your expression. Okay, guys. If I happen to take the negative sign in, it will change to xi square minus xf square. Now, I'll take a special case, or let me make a general statement from here. What is that we're looking at? The work that I do, it depends on what? Here we can infer the following. Work done by spring depends on, what does it depend on? K is a constant, 2 is a constant. It depends on xi, that is your initial, xf, that is your final position, right? So from this, actually let me write one more statement. This is one. Let me take a special case. Let me do it here. Case, if your initial position is x meters away, and your final position is also x meters away, then the work done by the spring can be written as this, right? X square minus x square is 0. So we have 0 joules. Is it not, guys? So from this result and from this result, from 1 and 2, what can we infer? That spring force has properties of conservative forces has properties of a conservative force. Is it not? What does it mean? If my displacement, if I start and end with the same position, I have done no work. There's no change in energy. We got that answer. My work depends only on the initial and final position, not the path independence. So this is nothing but path independence. And this is the what is that, closed loop property. Closed loop property. Does it make sense? So yeah, spring 2 is a simple force, and the numericals are not that difficult, honestly, handleable.